We're studying IGCSE chemistry and we're starting electrochemistry division 2. To recap, someone tell me what was the last thing we did in class?
We talked about the electrolysis.
Electrolysis, right?
And
What is
aqueous,
electrolysis? And
aqueous compounds.
aqueous compounds, okay. But aqueous electrolytes.
And we learned about the uses of electrolysis and types, products, and net ionic equations.
Okay, net half and net ionic equations.
And we did
fine.
the reactivity series.
Reactivity. Well, those are rules. So rules
And for
aqueous
today's
electrolytes.
class, we'll be learning about electroplating.
All right. So for today's class, you'll be learning about electroplating. Agenda. We don't get so much time every day, so I only have 2 classes with you for each subject. So we need to make most of it. Let's see how we'll do that. First, before we look at electroplating, we look at more of aqueous electrolysis. Aqueous electrolysis. How does that work? Well, let's look at an example. Example number 1. Write today's date and start. Looking at aqueous electrolysis. Yep. To start off, actually, let's go back to yesterday's notes, and we'll see from there what have we done so far. All right, guys, can you see the whiteboard?
Yes, sir.
All right. Now, that's physics. No, not this one. From right here. So we looked at the rules for these guys. Aqueous products at cathode. Or the rules for aqueous electrolysis. Let's put that right there. Aqueous electrolysis. Now let's continue from right here. I'll put and 2. Now the last example we looked at was for sodium oxide. Well, today we'll do more examples because we didn't really do any examples in the last class. Example number 1. First example, let's take LiSO4. Or instead of that, let's take NaCl, which is dilute NaCl. The name for this is going to be dilute sodium chloride. Write this in your notebook. Now, the first step always, there's a proper method to this. The first step is always going to be, we have, which is ions. Now, what ions do we have? Let's start with the ions. Sodium chloride, that means it is NaCl. So, Najla, tell me which ions will I have?
Yes, sir.
Yeah, so I have dilute NaCl aqueous. What ions will this electrolyte give me?
Positive and negative.
Positive and negative, Na plus and Cl minus. Diana, will I have anything else other than these? Mawadda, Diana.
I don't think so.
Lula. Well, we'll have something here, which is aqueous. What is that? Give us H plus and OH minus. That aqueous right there tells us that we also have water over here. What we have is, we have this water, and mixed with the water, we also have something else, which is NaCl. So I have a mixture of these guys. All right? That's what I have. Now, from the water, I get H plus and OH minus. From NaCl, I get Na plus and Cl minus. Now, our job is to realize in this electrolyte, we have the big one and the small one. The big terminal, the small terminal. The big one is positive, small one is always negative. The positive terminal is called anode. The negative terminal is called cathode. Fine. Now the ions I have inside here are Na plus, Cl minus, H plus, and OH minus. Now the next thing we have to do is look at the product. What products will I get? Well, I'll get products at two places, anode and cathode. Now, when I'm trying to
Sir,
find
I
the
have
product,
one doubt.
yes, ask me.
The hydrogen, the positive one, it should be with the cathode.
No, these are randomly mixed. They're not going anywhere. I can put
Okay.
this guy here. I can put this guy here. So they're in the
Okay.
solution. And there are hundreds of these, millions of these,
So
not just
it
hundreds.
doesn't specify whether they're positive or negative.
Now they're in the solution, they are positive and negative, but they haven't gone to the anode yet or cathode. They can be anywhere,
Okay.
right? Let's say the switch is on right now. It's not closed. Or the switch is off. So when I put this there, it will turn on. Okay. Now I've turned it on. Imagine I've turned it on. What will happen to these ions? Where will they go? So in the solution, I have these random ions mixed together, but they will go somewhere because of the electricity. The positive guy is going to pull the negative person. The negative person is going to pull the positive person. Opposites attract. So anode and cathode. How do I find how do I find the product? Well, the product is, I know that the less reactive forms always at the anode, at the cathode. Let's look at the cathode first. So if I go above, And from previous classes notes, please write one more thing over here. In previous classes notes, just add one line, that is less reactive forms. Now, Mavadda, read the rule, quick.
Only if copper, AgAuPt metals less reactive than hydrogen present, then they form. Otherwise, always hydrogen H2 gas forms. Lesser reactive forms.
So lesser reactive element forms. That's what the main rule is. And we know that lesser reactive element forms. So what is lesser reactive than hydrogen? Okay, let's see. Between hydrogen and Na plus, which is less reactive, which is lesser reactive. Let's see. I'll write the reactivity series right here for you. So we have kan kama zaf zaf ka. It's like a spell, Harry Potter. So kan kama zaf zaf ka. We have this thing. Let's fill it up. We have potassium, sodium, calcium, magnesium, aluminium, zinc, Fe, Sn, Pb, Cu, Ag, Au, Pt. Now, can you tell me what is less reactive than hydrogen? Hydrogen is between lead and copper always. So what is more reactive? Or what is less reactive? Sodium or hydrogen? Tell me.
Hydrogen.
Hydrogen. All right. Anyone else? Let's say Najla, what is less reactive? Hydrogen or sodium?
Sodium.
Sodium. And now I have two answers. Na or H. Now let's do a voting. Whoever is on the Na party, okay, Na side, say yes.
Sir, repeat the question.
The question is what is less reactive, sodium or hydrogen? So whoever says sodium, say yes. Who says that hydrogen is less reactive?
Me.
I
Okay,
would say sodium.
all right. And Liana and Niranjana, what is less
I said
reactive?
hydrogen. Yes.
Hydrogen. Niranjana, what is less reactive? With this reactivity series, is hydrogen less reactive or potassium? Or sorry, sodium. Sodium or hydrogen, which is less reactive? This guy or this guy? Hydrogen. Now, okay. Niranjana. Perfect. So what we realize is, yes, hydrogen is less reactive. Why? Because it's lower. What is lower? H or Na? Hydrogen is lower. So whatever
H.
is lower is going to be less reactive. So yes, then we can also say hydrogen is a loser and sodium is a winner. We're just saying what is less reactive. So if you are lower on the list, then you are less reactive. Let's not call hydrogen a loser actually. They're just
So the
different.
reactivity series, does it go like the stronger is down or like the ones that reactive the most are up?
All right, let's try to think about it. Now, Lula, what are more reactive? Copper or alkali metals?
Copper between all the alkali metals.
So between alkali metal and copper, what do you think is more reactive? Now I'll tell you right now, actually, never mind then. Alkali metals are the most reactive. What are alkali metals?
The most reactive.
Most reactive, group 1. So what I realized from this is then, well, potassium and sodium are most reactive, so they're high. So what we realize is If I go downwards,
It,
then reactivity
uh,
also down decreases.
but in the periodic table, the most reactive are the ones that are below.
No, it doesn't work like that. It's not always like that. Different groups have different patterns. Now we should have done the chapter on periodic table first. We'll do that as well. But for now, there's no need of that. All you need to see is reactivity. The lower you are, the less reactive you are. The higher you are, the more reactive you are. Fine.
Okay.
So since hydrogen is less reactive, the product at cathode is going to be H plus, gives us what? H2 gas. Now, what should I add to get H2 gas? Well, I should add
2.
2 electrons. 2H plus here, and I should also add 2 electrons. Now at anode, I have dilute NaCl, or that means I have Cl minus ion and OH minus ion. Let's look at the rule right here. Niranjana, read the rule.
Yes, sir.
Read the rule for aqueous products at
If
anode.
concentration highlight ions FClBr present, then they form. Otherwise, always hydroxide O2 gas forms.
All right. Now, so what that means is, can someone explain what that means? Lula, what does that mean? We did this in the last class. What that, actually tell me after this, all right? First, I'll tell you. Everyone focus. Listening?
Yes, sir.
Now I'll tell you. If concentrated ions are present, such as the halide ones, only the halide ones. So if I have concentrated Cl minus ion, or I have something which is concentrated and it has Cl minus ion, or any halide such as FCl, Bri, if these are there, then they will form. Well, CrCl will form, Br will form if they are there and they're concentrated. Otherwise, always hydroxide forms, which will give us O2 gas. So let's see.
So can you repeat?
I'll repeat. If I have concentrated fluorine, chlorine, bromine, or iodine, or any group 7, I've concentrated group 7. Just a second. Group 7, okay, if I have this one, which are also called halides, by the way. Halides. If I have these ions, concentrated group 7 ions, then they will form. If these are there, they're going to form. But if they're not there, then always hydroxide will form to give us oxygen. Is that clear?
Yes, it's clear, but to form what? If concentrated halide ions, they will form, they're present, then they will form, but they will form what?
All right, I'll tell you what they form what. Add this in your notebook. They form themselves. They form, let's just say, X2 gas. Yeah, okay. Add this in your notebook, all of you. I don't know how I forgot that, but it should have been there, right? So they form X2 gas. What is X2? X is basically any of these, F2, Cl2, Br2, I2. And Najla, were you there in the last chemistry class?
Yes, sir.
So check your notes and write this word, X2 gas.
Okay.
Then right before F, write X is equals to. Put this right there. X is equals to. Don't write the whole thing again. Just add X2 gas and before F, write X is equals to. If you can, also put a negative sign after all of these guys. That's it. Diana, finished?
No, sir, I'm still writing.
Now, okay, are you writing the whole thing again?
No, just the down part.
All right. Well, you just have to add this line, the yellow highlighted one, to form X2 gas. Just add this word right there. Niranjana, have you finished?
Yes, sir.
Okay. Then we're going to go downwards. Mawadda,
Yes.
have you finished?
Yes.
All right. So let's just recap one more time. If concentrated halides are there, then they will give us the X2 or any halide X minus, one negative ion, right? Negative ion will give us X2 gas. If it's not, these guys are not there, then only this will happen. Otherwise OH minus will give us O2 gas. The equations are here. By the way, if you haven't written these equations, please write them. Have you written these? Lula, check.
Yes, sir, they're written.
They're written. So that means I did tell you what X was, right? So this is the equation. If you have concentrated halide, you get 2x
Yes,
minus
I
gives
think
us.
you gave us, but you forgot to mention it up there.
Yes, we didn't mention it. Now let's go back to the question. And over there, we're going to use our newfound knowledge, because now we have all the knowledge we need and we can apply it. Utilizing your information is the big thing. Knowing is good, that's fine. But to be a pro, you have to basically apply it. Now we have Cl minus and OH minus. And we also have dilute right here. So can you tell me what will form? OH minus or dilute Cl minus? Diana, tell me.
What's the question, sir?
The question is, what is the product at the anode? I have these two options, either Cl minus or OH minus. Which of these will go to the anode?
Between Cl minus and OH minus?
Yes.
None of them.
None of them? All right, that's one answer. Najla, what do you think?
The Cl minus.
Cl minus, that's another answer. Now, Niranjana, what do you think?
Yes, sir.
Between Cl minus, dilute
Yeah.
Cl minus, and OH minus, which will form at the anode?
Not, it will be Cl minus. No.
Are you thinking?
Yeah. Sir.
Lula, what do you say?
I would say if it's anode, the OH minus and Cl minus will go.
Okay, that's fine. So we have these two options, Cl minus, OH minus. But between these, what will form? That's the competition. Between these, you have two options now. Not both of them will go. So what we know is, Mawadda, tell me, do we have concentrated halide over here? Concentrated chlorine.
Do we have what?
Concentrated halide.
Yes, we have chlorine.
We have chlorine, but do we have concentrated? We have dilute, right? What do we have?
Dilute.
Dilute. And versus that, I have OH minus. And as per the rule, I know that if I don't have concentrated halide ions or concentrated group 7 ions, then always OH minus forms. So the answer will be OH minus. And the equation is OH minus gives us O2 plus 2H2O plus 4 electrons. Any questions? Let's try another example.
So what's the answer, sir?
The answer is OH minus. That forms. And not this guy. Why? Because this is dilute chlorine. For it to form, we need concentrated halide or concentrated chlorine. So I don't have concentrated chlorine, so OH minus forms. Finish writing this in your notebook. Now example number 2. Let's take the example of copper fluoride or concentrated, let's say dilute. Now let's take concentrated NaCl, aqueous. What are the ions present, Luna?
Na plus and Cl minus.
Okay, Na plus and Cl minus. What else?
H plus and OH minus.
Yes, because it's not molten, it's aqueous. So that means there's water there. Water will form H plus and OH minus. Now the products. For the products, we need to know what will form at anode and cathode. Now, Niranjana, what will form at the cathode? Positive or negative ion? Niranjana,
So,
what will form at the cathode? Positive ions, these guys or these guys? Negative ions?
so positive ones.
Positive. Now, Diana, tell me, between Na plus and H plus, which will form at the cathode?
Na plus.
Na plus. Now the thing is, what is less reactive, Na plus or H plus? Or sodium or
H
hydrogen?
plus.
H plus, or H plus will form. Right? H plus forms because it's the same thing. Sodium and hydrogen, between the first example, second example, same thing. So the one which is less reactive will form. And what that means is the only ones which are less reactive than hydrogen are copper, silver, gold, and platinum. If you don't have these guys, then it's always going to be hydrogen as the product. Because those are the only ones which are less reactive than hydrogen. At the anode, we now have concentrated, and we also have chlorine and OH minus. Lula, can you tell me what will form at the anode?
It will be this time chlorine.
Chlorine. What is the equation?
It will be Cl minus equals to O2 plus 2.
Okay. Cl minus gives us O2 plus 2. Actually, let's look at the rule again. That's in your notebook. We just have to apply it. What is the equation when I have an halide present? Look. What is the equation? Read this out loud, Lula. Lula?
Yes, 2x minus equals to x2 plus 2e minus.
All right, so it's not equals to, no, maths, chemistry, that means gives, or gives us, or basically gives. So 2x minus gives x2 plus 2 electrons. So right now I don't have fluorine, I have chlorine. So in place of x, I'll just put chlorine. So what is the equation, Bhavata?
2Cl gives the product Cl2 plus 2 electrons.
That's 2Cl minus.
Yes.
All you have to do is replace the x. I hope that's clear. Any questions?
And the X will be replaced only with the halide, the group.
Yes, halide, which is present, and if it's concentrated halide.
Only concentrated. Okay.
Yes. So we'll just write it here. Cl minus, 2Cl minus gives us Cl2 gas plus 2 electrons. This gas, the product is important. These are aqueous, by the way. And that's gas. Please write the whole thing in your notebook. Tell me when you're done. Now, Niranjana, I want you to work with me on this.
Yeah, sir.
Now, between Cl minus and OH minus, which guy will form?
Yeah.
Between Cl minus and OH minus at the anode, both of these are negative. So negative goes to positive electrode, fine. But which of these will form? The one that forms is, if it is concentrated group 7 or concentrated chlorine, then it will form, all right? It will form the chlorine gas. If this was dilute, then chlorine would not form. Then OH minus would form. Any questions? Please finish writing this, and we're going to look at a few things. In the last example, there's one more thing remaining. That is, what is remaining in the solution. So in the solution, if OH minus is gone and H plus is gone, Lula, can you tell me what is remaining then? OH minus goes away, H plus goes away. What is remaining? Example 1.
We have learned that nothing will be remaining.
No, that's only for molten. But right here, H plus goes away and OH minus goes away. What is remaining?
Na plus and Cl minus.
Right? So in the solution, NaCl is remaining. Is that clear?
Yes.
Now in this one, Najla,
Yes, sir.
in this, Cl minus is gone away, well formed at the anode, and H plus has gone away. What is remaining in the solution?
Na plus and OH minus.
So what will they form? They will form, come on, Na,
Na plus and H minus.
OH minus, but they join together to make NaOH. Is that clear?
Yeah.
So NaOH together. This is called sodium hydroxide. This reaction is very important, by the way. We'll look at it again afterwards. First, let's practice more questions like these. Now, for all of these, have you finished writing?
Yes.
Diana, Niranjana, have you finished writing?
Yeah.
All right, that's good. Good job. Mavata,
Yes, I finished writing.
finish. Now, example number 3.
Sir, normally wouldn't we calculate like add? We used to add.
Net equations, half equations, right?
Yeah.
Now we're only looking at products right now, so we'll do that later, right?
Okay.
Now we need to know what's forming first, then we can, adding is the easy part, we can do that. But realizing what is forming is the big thing. Now another example could be, let's say, next example is, well, we'll take copper of constant, let's say, dilute copper chloride, CuCl2. Now let's write it separately. Copper chloride. This is what I have. So, Diana, give me the ions. First step is ions. Tell me.
Copper, chloride,
So copper 2 plus and Cl minus. What else do we have? Do we have anything else?
yeah, water, aqueous.
So H plus and OH minus. So that water gives us these ions. Next thing is we look at the products. Now for this one, we have anode and cathode again, fine. But there's one more thing we need to look at. We now have a bit difference in the cathode. Let's see how this is different from the other examples. Now, which of these guys will form at the, which of these, all of these, will form at the cathode?
Cu plus, Cu2 plus and H plus.
So, well, okay, these guys are the competition. They're going to fight each other and we'll have a match. And your job is to tell me who's going to win. You are the judges, all right? All of you are the judges, and you have to tell me if Cu2 plus and H plus fights in a deadly match, what will happen? We know at the cathode, these guys are going to form fine. But we also know that the less reactive one forms.
Yeah, so it will be Cu2 plus.
So Cu2 plus,
Yeah.
yep, gives us Cu. And how many electrons should I add?
Two electrons.
Two electrons.
For the anode, Diana, tell me what will form.
Between
Diana?
H plus and
No, between these guys, negative ones. The negative ones go to the positive person, or the positive anode, electrode. So on the anode, what is going to form? Cl minus or OH minus? It's also dilute, by the way.
OH
Now the one who
minus.
OH minus. What is the equation? Mavadda? Now whoever says the equation gets 2 points.
OH minus gives us O2 plus 2H2O plus 4E minus.
All right. Now something is missing here. Whoever tells me what is missing gets 2 points.
Aqueous.
Where aqueous?
OH minus.
In OH.
Okay, fine. What else is missing? There's a lot missing actually. There's one more thing missing.
Liquid in H2O.
All right. What else is missing?
Gas on
Gas.
oxygen.
Yeah.
Yeah.
Right. All right. So the people who get 2 marks are, well, Luna answered first. She gets 2 plus 1, 3 marks. Diana, Mavadda. Niranjana was not there. Niranjana, can you hear me?
Yes, sir.
I want you to take part as well. Answer questions. Now, can you tell me what is missing in this equation, the second one? A state symbol is missing. What is the state symbol of Cu2 plus?
It is solid.
Never solid is the one
Yeah.
which forms as a solid. But these guys are in the solution, so they are aqueous.
Aqueous.
Perfect. Any doubts in this? Now, last
No,
thing
sir.
is, what is remaining? Now, whoever tells me this gets 2 points.
HCl.
HCl, are you sure? Sure? Yes.
Yeah.
That was Najla. Najla gets 2 points. Now we have the leadership happening right here. And if so, the person with more marks is actually, or the person with the most marks is the best. Let's look at another example. The final one.
Wait, sir, can you show me again the anode?
Yeah, write this in your notebook, all of you, actually, and tell me when you're done writing. Now, first step, Niranjana, give me the ions.
Al.
We have A, which one? A what?
Al minus and sulfate, it will be
Sulfate. Sulfate is S,
SO4 3 minus
2 minus.
2 minus.
Now, all of you have to memorize this. SO4 is always 2 minus. Always. Now you can write this as well. Always. This is AU, not AU, AG. AG is not always 2 plus, but we write it as 2 plus. So mostly, we can say this is mostly 2 plus. Mostly. Now, next thing is, we look at, let's take another color. Najla, what is your favorite color?
Yes, sir.
Black.
Niranjana is
Me?
black. Yeah, okay. Niranjana, Najla, what is your favorite color?
Blue.
So since we have done black already, we'll try to. Now, second one. What are the products? Quick. Anyone
Anode
who
and
answers
cathode.
first. Yeah, anode and cathode. What are they? Now, this one I want you to do on your notebook and send me a picture.
Okay.
Only the cathode one.
We only do the cathode without the anode.
Without the anode, yes. And Niranjana worked with me. Niranjana? Niranjana? Out of class. Now, Diana worked with me.
Okay, sir.
Is something missing in this, in the ions?
Aqueous.
Aqueous, what are they? What does that mean?
OH and H.
H plus and OH minus. Perfect. Now in the products, what will I have at the cathode? It's going to be between these guys because they are positive, they go to the negative electron.
And the cathode will have the H and OH.
Now the cathode will have this. I'm sorry. What will go to the cathode? These guys, the positive ones, because cathode is negative. These guys go to the cathode. And my job is to see which of these will go to the cathode. Now, what was the rule? Tell me.
Sir, I send my answer.
I haven't gotten it. Diana, what is the rule for the cathode products? Mawadda, what is the rule for cathode products?
What's the rule for what?
Cathode products. The products are the cathode, right?
It have to be the least reactive.
Least reactive, and you must have written it in your notebook from the last class. That
Yes, it is
if
there.
I have copper, gold, silver, platinum, these four, then these guys will form, right? They will form what? They'll form the solid of themselves. Otherwise, H plus will form. That is the rule. Or whatever is less reactive will form. So that is what we need that is what we need to know actually. So we'll write it over here. Let's see any answers.
I send you mine too.
All right. Let's bring it right here. So Ag2 plus gives us this, that's correct. And this is correct. Now, how do we get Ag2 plus? Because the rule is that whatever is less reactive, Mawadda, that forms. That is the rule for the cathode. So, since I know that Ag2 plus is lower in the reactivity series, let's look at the reactivity series right here. Ag2 plus is, or A silver is right here. So it is below hydrogen. So it will form. So the answer will be cathode Ag2 plus 2 electrons gives me. Now, Najla, you're missing the state symbols in the second equation.
Yes, sir.
Now, metals are always solid. So you need to write that solid one there, S. Now, it will be very important in the coming questions that we need to write these right now. Now, anode we know. Niranjana, work with me.
Yes, sir.
What do we have as negative ions? Because our anode is positive, so negative will go there. So we have sulfate and hydroxide ion. Now, which of these will form? One thing I can tell you is, you must have written this again in your notebook from the last class, that complex ions never form. What happens? Complex ions never form. Niranjana, say it after me.
Complex ions never
Form.
form.
So the answer remaining is this guy is not going to form. Then this must be the one. Niranjana, give me the equation for OH minus. What does it form? Lula, your answer is correct. Good job. Liana, send me your answer. And Mavadda, send me your answer.
For which question?
Question 4, exercise 4. So only this part is remaining. You have to finish that and send it to me. Niranjana, come on. So what is the equation for this? Niranjana, can you hear me? Now we have two things. Either
Yes, sir.
tell me the answer,
I'm
or if
still
you don't
hearing.
know, then tell me. We won't think too much. So don't think too much, no tension. Just tell me if you know or if you don't know.
No, sir.
No, then I'll tell you. The equation is always going to be 4OH minus gives us 2H2O plus O2 gas plus 4 electrons. This one you have to memorize it. Is that clear? Now, Mavadda, tell me what is remaining in the solution.
Is it the oxygen?
No, oxygen goes away. All of these things are no longer in the solution, in the electrolyte. These guys are at the anode and the cathode. So what is remaining now?
Silver?
Silver and no, silver is also gone, by the way. Silver is not remaining. Look, silver is going to the cathode. So what is not going to cathode or electrode?
Hydrogen.
Sulfate.
Hydrogen and sulfate. So what is left in the equation? H plus and SO4, 2
SO4.
minus, which will add up together to give me H2SO4 because we need two of these, and this will give me H2SO4. Like this. So in the solution, we have H2SO4 remaining. Any doubts, anyone?
I
Niranjana?
said the one that
No,
me and
sir.
Najla with the anode
No,
that we
sir,
just
not.
sent, we didn't add 4 on it.
You did
I
not?
added 4.
Well, I didn't.
No, you have to, you should, you must. You have to, you should, you must, right? No, Najla, you did not either. Put it there.
The plus 4E minus?
No, not that one.
No, no,
This
at the
one,
top
4OH.
anode, 4 OH.
4OH.
Oh,
It has to
okay.
balance. Look, how many hydrogen do I have? 2 H2O,
4.
that means 4. And I have 2 oxygen as well. So 2 over here, oxygen. And I have 2 oxygen here, that means I have 4 oxygen. So I need to have 4 OH minus here to balance things out. Now, since that is done, I'm going to give you some questions from the past papers. There are a few things remaining. Let's start with the new thing, okay? Well, before we start with the new thing, actually, let's just focus on this a little bit more with a past paper question. Now you guys can take the booklet for chemistry, which has over 1,000 partial questions topic wise for each chapter. For this chapter, I think we have about 80 questions, both MCQ and theory. So 80 theory questions, 80 MCQ questions. That should be more than enough for practice. It's quite cheap as well. All right, read the question. Najla.
Chemical reactions are
Chemical
always
reactions are
Niranjana or Najla.
So you should label them. Nickel
Yes,
and
alright. Now, sodium, please read the question. With the
Okay.
Na, Najla.
Yeah,
Yeah.
chemical reactions are always accompanied as an energy charge. Question number A. Aluminium is extracted by electrolysis of molten mixture which contains aluminium oxide. This decomposes to form aluminium at negative electrolyte and oxygen at the positive electrode.
All right. Now, Diana, read. Continue. Part 1.
Write an ionic equation for the reaction at the negative electrode.
All right. Now, what is the electrolyte here? The electrolyte is Al2O3. Is molten Al2O3. Al2O3. Now, first, tell me what are the ions? Lula, Mawadda, ions.
Al2 and
Al2?
O2.
No, these are not ions.
Al and O. Al minus and O. I mean this
Correct.
Al plus.
Al3 plus, O2 minus. You just have to look at these numbers. So this guy is for this one, and this 2 is for this one right here. So what do we realize from here? We realize that we have these ions and the products now. Mavada, tell the product for
Anode
the
and
anode.
electrode. Cathode.
But they're not asking for the anode, they're asking for the negative electrode. Okay, negative electrode. How do we know this? Which of these is negative? Anode or cathode? Which of these is negative?
Cathode.
Cathode. So tell me the product at cathode. I have these guys.
Aluminium.
So Al, say the whole thing.
Al 3 plus.
Gives us plus what?
3E minus.
Plus 3 electrons gives us
Al.
Al. So Al3 plus 3 minus gives us Al. Now the other one is complete the ionic equation for the reaction at the positive electrode. Now this one is actually not the one which we know so far, all right? But we can still try doing it. If O2 minus is forming at the positive electrode, look at this. What is forming at the anode? Can someone tell me?
The negative one, yeah. O2 minus.
O2 minus plus, or what is the equation?
It will be O2 minus gives us O2 gas plus 2E minus.
Plus 2E minus. But the problem is, on this side I have O2, but here I only have O. I have 1 oxygen on one side and 2 oxygens on the right-hand side. So it must be balanced. How do I balance it?
We
Add,
add O2
two.
plus to the other side. Yeah, two. I mean, yeah,
O2.
2.
2, and this will become 4 electrons. Any questions?
No, sir.
No.
Now, does this look similar to this one? So what are the fill in the blanks here?
It will be
2O2 minus is already written, gives us O2 gas plus 4E minus.
That's it. Any questions, anyone?
No.
Niranjana, Nikhil?
No, sir.
All right. Is the reaction endothermic or exothermic? Explain your answer. Well, we need to know that aluminium extraction is electrolysis. Okay, they're asking for which equation actually. Okay, now, are these reactions endothermic or exothermic? Can you tell me? I haven't told you yet. So please write in your notebook. The question is electrolysis endothermic or exothermic? The answer is electrolysis is exothermic. Why? You need a reason for this. You can't just say it is. You need to give the reason as well. Reason: electrical energy is supplied for reaction to occur. So whenever you're applying some energy, you're giving some heat or something, then the reaction is happening. That is called endothermic. Sorry, this is endothermic. So because you're giving something. If you give something and then the reaction happens, it is endothermic always. But if you don't give anything and you get something such as heat, then it is going to be exothermic, because exothermic releases heat and endothermic takes in heat. So it's taking something from you. If you don't give it electricity or heat, it will not. The reaction will not take place. It will not occur. On the other hand, exothermic occurs on its own and it gives you heat. Finish writing and tell me when you're done.
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 Mawadda, finished? Now that's it. For we also have something called electrochemical cell. We'll do that in the next class. Now, so we'll write the answer here first. Why is it endothermic? Exothermic or endothermic? Endo. Because electricity is supplied. Now this one is, we haven't done it yet. So let's see what we have to do in the next class.
Sir, can I tell you something?
Yes.
If you will repeat for them the first 4 chapters, I'm gonna repeat it with them again.
That's fine. We will repeat it.
Yeah.
Yeah, but you don't have to, not right now, because
Ye-
anything you need in the first 4 chapters, I will teach you while teaching the other subjects. Not the other subjects, the other chapters. So in electrolysis, if you need something from chapter 1, I will tell you. So by the time you finish chapter, let's say when the time you reach that chapter 15, you'll automatically know chapter 1, 2, 3, 4. All right? So we don't have to go back to those chapters. Those are basic chapters. Because these are more
I'm just
important chapters.
telling you in case you repeat it for them.
Yeah, it's fine. It's fine. Thank you for telling me. And I'll keep it, I'll note it down. So next class is electroplating and refining metals. Now, Diana, recap, what did we learn in this class?
We talk about aqueous electrolysis and the rules, and
Okay,
about
that seems about it, right? We looked at,
We also learned about dilute, molten, and aqueous.
all right. Now, Najla, anything else?
No, sir. Thank you.
All right. Then that's it for now. I hope you understood whatever you learned today, and you have a worksheet in the GCR. You'll have electrochemistry now. So whoever hasn't finished equilibria, whoever hasn't finished metals, they should. Now you have electrochemistry worksheet. That's all for now. Just a second.